So we're going to continue this lesson where we left off yesterday. So in this example, they give you a trig ratio and they give you the value of cosine. So using our SOHCAHTOA, we know that the values that they're showing us represent the adjacent over the hypotenuse side of the triangle when we're sort of talking about that reference triangle. So for the time being, we're going to sort of ignore this negative sign and we're going to deal with it differently. So this negative sign will lead us to cast, and the cast rule, remember, we write our cast in and we want to find the quadrant where cosine is negative. So cosine would be negative in the quadrant that doesn't have the C in it, because that would mean cosine's positive. So in the S quadrant, cosine would be negative, and the T quadrant, cosine would be negative. So I'm going to ignore the negative sign. This tells me that I'm in quadrant 2 or quadrant 3. And then if we keep reading the question, it tells us that the theta lies in quadrant 3. So now, based on that sign, the negative sign value, we're going to draw our angle in quadrant 3, and this angle in red would represent the angle that they're referring to, theta. We want to find the exact values for sine of theta and tan of theta, where theta is referring to the red theta that we have here. And in order to do that, we need to look at our reference triangle, which would be theta referenced right here. I'm going to create a reference triangle by dropping down that terminal arm to the closest x-axis. And I'm going to put the values on here. So this 3 represents my adjacent side, and this 4 represents my hypotenuse side. So here's theta reference. Opposite would be nothing. Adjacent would be 3, and hypotenuse would be 4. Now we've done it both ways. You guys know that I don't like to put the negative on the 3, but if you wanted to, you could put the negative on the 3, recognizing that we are in quadrant 3, and that negative means that I'm having negative x values for sort of that location. We're going to use Pythagorean theorem to solve for our missing variable y here. So I'm given the hypotenuse, 4 squared is equal to 3 squared plus y squared. Again, we're not putting negatives in our reference triangle at all. So when I square these values for Pythagorean theorem, I would just put a 3 squared. 16 is equal to 9 plus y squared. So y squared would equal 16 minus 9, which is 7. So y equals plus or minus root 7. Now from here, we could look at the fact that y lies in quadrant 3, and we can say, okay, well, the y coordinates are negative, or we could say that the value of this y would be positive root 7, and then put a negative sign because it's sort of attached to the fact that it's in quadrant 3. So we could write negative root 7. Some of you have liked doing that. So now we would do sine of theta. So if you put the signs in your diagram, then you don't really have to worry about the cast rule, but you do have to worry about the signs on the values. So sine of the theta in red would be based on sine of this reference angle, which is opposite over hypotenuse, negative root 7 divided by 4. Cosine of my red angle will have to be based on signs and location. So cosine would be opposite adjacent over hypotenuse, which would be negative 3 over 4. And we want to represent these in exact values, which means we want no decimals, period. So do not put any of these in your calculator and write an approximate decimal or a decimal of any sort. Okay. Now we're going to continue with trig ratios. Yesterday's lesson, we found the values of x, y, and r. Basically, that was referring to our angles in standard position. If this was my reference triangle, this would be my X, this would be my Y, this would be my R, and we wrote SOHCAHTOA using our X, Y, and R. So we had talked about sine of theta would equal Y over R, opposite over adjacent, or sorry, opposite over hypotenuse. We talked about cosine theta being X over R, which is adjacent over hypotenuse, and tan of theta equaling Y over X. So you can kind of think about these values as X's, Y's, and R's, or you can just think about it as SOHCAHTOA with your opposite, adjacent, and hypotenuse on the reference triangle. Okay, now why are these ratios useful? We use these ratios to solve for the theta, which is our rotational theta. So that would be an angle in this case between 90 and 180. Our answer has to be between 90 and 180 in this case, by using the appropriate inverse trig ratio, by using the appropriate inverse trig ratio. Or well, we can call it the function. Sorry, we can call it the function. So inverse trig function on our calculator. So on our calculator, this would be either the sine inverse, cos inverse, or tan inverse buttons. So I'll kind of briefly show you kind of where it would look like on a TI, an approximate place, and then the Casio would work very similarly. So we could have second sine, that would be the finding the angle using a sine ratio. We would use second sine to find the angle. We could use second cosine to find the angle, or second tan to find the angle, but we want to make sure we have that -1 right there as we're finding the angle. And on a Casio, it would be the same thing. It might be shift sine, shift cos, or shift tan. Okay, you got to be aware, and this is the tricky part, that the theta on our calculator will always sort of represent a reference angle. So if you do something where you put something in your calculator and it gives you a funny answer, the calculator is being a little bit funny and it doesn't really know how to take in angles that aren't reference angles. So what we want to make sure is that when we're typing in sine inverse, cos inverse, tan inverse on our calculator, we're only typing in positive values, okay? We're not doing cast at all in terms of finding our reference angle. So we'll just kind of show you a brief example. I gave you an example yesterday, which was the point on the terminal arm. So -8 and 15 would be somewhere here. I draw my reference triangle, dropping it down to the x-axis, the closest x-axis. This would be my rotational theta. And my reference theta would be the angle that's in the triangle. And this value would be 8, and this value would be 15. If you're paying attention to the red angle, you are allowed to show that kind of as a -8. But what I'm going to do is I'm going to just pull out the triangle on the side. And this would be theta reference. I'm going to only represent this using positive angles because it's my reference angle. So 15 squared plus 8 squared equals h squared, and I'm looking for my hypotenuse. So 15 squared plus 8 squared is 289, is h squared. H is equal to plus or minus root 289. I need both values when I'm solving the square root. And then again, because we're talking about our reference angle and our hypotenuse, the value is always positive. So we're not going to look at the negative answer at all. So this will give us 17. So we could do sine of theta reference, cos of theta reference and tan of theta reference, and just write those ratios using either these relationships, y over r, x over r, and y over x, or just remembering your SOHCAHTOA. So sine is opposite over hypotenuse, which is 15 over 17. Cosine would be 8 over 17. And tan would be opposite over adjacent, so 15 over 8. Now, if I were to use the appropriate inverse trig function, I could do sine inverse of 15 over 17 and get an answer. I could do cos inverse of 8 over 17 and get an answer. And I could do tan inverse of 15 over 8 and get an answer. Now, because these all represent my theta reference, or a representation of it, it should give us the same value. So let's go ahead on our calculator and take a look at that. So if I do second sine and type in the value 15 over 17, it gives me an angle of 61.92 blah 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 degrees. If I do cos inverse and I put those related values in, 8 over 17, I get the 61 degrees. And then if I do second tan and put the values in, I get 15 divided by 8, and I get 62 degrees approximately. Now, if your calculator is not showing these values, it's because you're on a different set of units for the angle on your calculator. So what you would need to do is hit the button that says mode. You can see that mine shows degrees over here, flashing. So if I go over here and your calculator shows the radians, you're going to move it over to the degrees, hit enter, and it will kind of highlight the degrees. You want to make sure your calculator is on degree mode, otherwise you're going to get the answers in radians, which you're going to learn about in 30-1. We don't deal with radians in 20-1. Now, radians is another measure for angles. We again want to be in degrees, and this gives us 62 degrees in all our examples. Okay, again, make sure, and I will remind you this, you are on degree mode on every test, because as soon as we reset your calculator, it automatically defaults to radian mode. So there's 62 degrees. We're not going to write this because I've shown you how to get the answer on the calculator correctly. So this represents 62 degrees in all cases. If you get an answer that's not consistent, it's because you're putting the signs on the numbers, and we don't want that when we're dealing with the reference triangle. So we know that this angle would be 62 degrees, and then I can go ahead and find my red angle, which is going towards the full line, is 180 degrees. I minus the angle that I've just found, which is 62, and I would get an angle of 118 degrees. So we again want to have no plus minus signs from cast included. So I say plus minus as in considering the sign, but basically you just want to leave everything positive. Now again, if I do cosine of theta, my theta would be using the red angle. I would have to use my cast rule or look at the signs on the triangle in that location. So like the -8, the +15, and the 17. My tan of theta would be -15 over 8. And my sine of theta would equal 15 over 17. So if you're writing the ratios for the angle theta, then what you would want to do is make sure that if you're using this to find your reference angle, you choose the positive ratio, okay? Or you ignore the signs on the other ones. So I could do theta reference, even though this is a relationship for theta rotation, and I could do sine inverse of 15 over 17. So it depends on how you've written your information. if they want sine theta, cos theta, tan theta, these are the ones I need to give as my final answer. But you can still get the reference angle by choosing the positive one and representing that using your inverse trig function. But if you did these ones, you can still find the reference, but you would ignore the negative signs. So again, this would be 15 over 8 like we had done above, or this one would have been cos inverse of 8 over 17. And again, if you forget and try them, you're going to get different answers, and then it's going to cause you a lot of confusion because you may not know what those answers mean. Now, we're moving on to special case triangles. So this is super important in Math 30-1. These triangles, you kind of have to know the values and know the angles in the triangles. If you don't like the triangle method, which me personally, I don't like the special triangles, I'm going to show you a hand trick that will give you the same information that the triangles show you. So as you're working, you have to either know that you're remembering special triangles or you're remembering the hand trick to get the values off the special triangles. So anything I box in this section is something you would have to memorize or kind of recreate using the triangles. So you have to sort of know your 90, 45, 45 degree triangle, which is essentially an isosceles triangle. So the word isosceles means two sides have the same values. So on my triangle, I have two sides that have a side length of 1. This makes this an isosceles triangle. This would be a 90-degree angle. So these two angles in an isosceles triangle would be the same. So if I do 180 degrees minus 90, because that's my one angle already over here, I get 90 degrees. So 90 degrees has to be divided into two parts. So this would have to be 45 and this would have to be 45 degrees because on an isosceles triangle, those two angles would be identical. Okay, now we would also want to find the hypotenuse. So 1 squared plus 1 squared equals hypotenuse squared. 2 is equal to hypotenuse squared. So hypotenuse is plus or minus root 2. But we only take the positive answer because h has to be positive. So this side is a length of root 2. And again, we don't want any decimals because we want everything with exact values. Now, the whole point of this triangle, you need to know the values and the angles on this triangle, this very specific triangle. And then you need to know the sine of 45, the cos of 45, and the tan of 45 using the triangle. So you can either have this as your angle you're looking from. This would be opposite, adjacent, hypotenuse. And then you just fill in the values. 1 over root 2, 1 over root 2, and then tan would be opposite over adjacent. So 1 divided by 1 is 1. So you need to know these exact values and how to get them, memorize them, use the triangles, or use the hand trick I'm going to show you because your hand is always on and you can kind of always have it in front of you if you need it. We also need to know the content of the 90, 60, 30 degree triangle, which you're either going to look at rotated this way and then kind of focus on our dotted line, or rotated this way. So I'm going to focus on it kind of standing up like this. And what we do is we take this line that bisects the triangle in half. So in an equilateral triangle, all the side lengths are the same. So when I take this orange line and bisect it and I pull out this triangle, this would be a side length of 1, which is half of the full length on the bottom, which is 2. This hypotenuse would be a 2, and I would need to solve for this side, which I'm going to call y. So 2 squared equals y squared plus 1 squared. 4 equals y squared plus 1. Y squared is equal to 3. Square root both sides, you get plus or minus root 3. And again, we only take the positive answer because we're dealing with sort of a reference triangle, and this would be a root 3 on that side. So this is the triangle you need to remember, or this one. Now, every angle in a isosceles triangle is the same, so these would be 60 degrees each, because the angle in an equilateral triangle would be, you have your 180 degrees divided into 3 angles, which means each angle is 60 degrees, and this angle at the top would be 30 degrees. So this is my 60-degree angle. This is my 30-degree angle because this orange line bisects it or cuts it in half. So the ratios I need to know are the sine of 60, the cos of 60, and the tan of 60 degrees. And the angles or the values of the ratios I also need to kind of have on hand by memorizing or remembering or using your triangles every time is cos of 30, sine of 30, and tan of 30. So first we're going to look at opposite, adjacent, and hypotenuse using my 60-degree angle, which is down here. So sine would be opposite over hypotenuse, cosine would be adjacent over hypotenuse, and tan would be opposite over adjacent. And then when I do the other ratios, at 30 degrees, I'm going to look at the 30-degree angle and label my opposite, adjacent, and hypotenuse. So now from 30, that would be opposite, the 2 would be hypotenuse, and then the root 3 would be adjacent. So sine would be opposite over hypotenuse, cosine would be adjacent over hypotenuse, and tan of 30 would be opposite over adjacent. So the values are very similar for 60 and 30, but the cosine and tans get reversed. The cosines and the sines get reversed and the tans become reciprocals of one another. So anything that has a 30, 45, or 60-degree reference angle, these would be our exact values, and you kind of have to know the content of this. So what I'm going to also do now is show you a hand trick, and I'm going to apologize in advance for the hand I'm going to draw because it'll be really bad. But this is your right hand facing you. Okay, this is my right hand facing me. So again, this is all like kind of my fortune lines here telling me I'm going to be smart and telling me I'm going to be rich and live forever, but we don't care about those. There's going to be an imaginary square root over all of your fingers, and there's going to be a 2 on the palm of your hand. So this is the palm of my hand. It kind of looks more like my wrist, but I'm talking about my palm. And then what we do is we start at the thumb and label 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So that's your right hand facing you, and those are kind of the values you have to remember on your right hand. You have to also remember that on the left is cosine and on the right is sine. So what's going to happen is you're going to bend a finger down depending on what reference angle you have. And then once that finger gets bent down, there's sort of 2 sides formed. There's the fingers on the left of the bent finger, and then there's the fingers on the right of the bent finger. The left side represents cosine and the right side represents sine. So let's just say I needed to remember what sine of 45 degrees was. What I would do is I would take my hand, I would locate my 45-degree finger, which would be this finger right here, and I would need to bend that finger down. So I'm going to kind of draw that bent down. There's my nail now with my cool nail polish. We're going to bend this 45 finger down, and so these are the fingers that are left on the right side. These are my sine fingers. And these are the fingers that are left on my left side, which are my cosine fingers. So if I wanted to do sine of 45, I would look at the 2 fingers on the left side in red, and I would write a 2 here. And then I would put the imaginary square root, because there's an imaginary square root over all my fingers. And then my palm would show a 2, and this would be a root 2 over 2, which is identical to a 1 over root 2 that has been rationalized. So anytime you see a 1 over root 2, it means the same thing as root 2 over 2. We can rationalize that and show you how that happens. If I wanted to remember the cosine of 45 degrees, I have 2 pink fingers on the right-hand side, or sorry, the left-hand side. So I count 1, 2, I write a 2, but put an imaginary square root on the top of it. I divide my answer by 2 because there's a 2 on my palm, and then that would be my final answer for cosine. And then my tangent would be my sine fingers divided by my cosine fingers. So I have 2 sine fingers, so I'm going to have a root 2 cosine fingers divide by root 2, and that simplifies to a 1, which is the same information I'm getting from above. If I wanted to do the 30-degree reference triangle, then I would put down my 30-degree finger. I would have 3 fingers on the left, 1 finger on the right, and I would continue that way. So I will kind of do it using the hand trick below, but if you like your special triangles, you can use that instead. So in these examples, the first thing you would need to do is find your theta reference, because I'm looking for the exact value of trig ratios, but I give you 0 numbers on my terminal arm. All I tell you is that I have a 135-degree angle. So if this is a 135-degree angle, that's the only information I'm giving you. So you'll have to clue in and remember that I need my reference triangles with the special triangles relating to this. So I want to find my reference angle, which is the angle dropped down to the x-axis. So what I'm going to do is I'm going to take 180 degrees, which is going all the way to the line, and subtract off the 135 degrees I've already traveled, and I get left with 45 degrees. So that's my reference angle. So once you know your reference angle, you're going to locate either the reference triangle that matches with that one, which is in this case the 45-degree triangle, or you're going to locate your 45-degree finger. So I'm going to do this using my fingers. So I'm going to just show it in step 2. 3, 4, 5. There's my right hand. 0, 30, 45, 60, 90. I locate the appropriate finger, which is this one, and I bend that finger down. So there's my nail, and I'm going to delete this part because now that finger is bent down. So it says to find the exact values of the trig ratios. So we need the sine, the cosine, and the tan. So my sine of 45 would be, I look at the fingers on the sine side. So there's 2 fingers. So I put a 2, but an imaginary square root. And then there's a 2 on my palm, which I would write it as root 2 over 2. To get the cosine of 45 degrees, and again there's an imaginary square root and a 2 here. I locate the fingers on my cosine side, which is this side. So I have 2 fingers, so I write a 2 and then a square root over it, and then put the 2 that's on my palm. And the tan of 45, what you're going to do is you're going to take the sine fingers, which is 2 of them. So I'm going to write a root 2, and then you take your cosine fingers, which is also a root 2, and you divide those, and you get simplified to a 1. So this is sort of my intermediate step. I need to do the sine, cosine, and tan of the reference triangle. And now what we're going to do is add cast. So sine of 135, cos of 135, and tan of 135. So these are going to be exactly the same as my reference triangle. So the 1, the root 2 over 2, and the root 2 over 2. And then when I write my cast rule down, my angle is in quadrant 2. So sine is going to have a positive because sine is positive in that quadrant. Cos is negative, tan is negative, and therefore this representation would represent my final answer. So you're either using your hand trick or you're recalling the triangle that we used above, which is the 45, 45, 1. And again, I never remember these triangles, which is why I'm looking. So this would be the root 2, 1, 1, 45, 45. And then you pay attention to the 45 and do opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and get the same values in step 2. And then you would use the cast rule in step 3. Now you'll notice that 1 over root 2 and root 2 over 2 look different, but 1 over root 2, if I rationalize that, I would use my radicals unit, multiply by root 2 and root 2. I get a root 2 on top. Root 2 times root 2 is just 2, and I get a 2 on the bottom. So literally 1 over root 2 and root 2 over 2 are exactly the same thing. I don't mind you writing them in either format. Now let's look at our next example. 240 degrees. My first step would be to draw the angle. 240 degrees lies in quadrant 3. My rotational angle would be 240 degrees. So we need to locate what the value of our reference angle is, which in this case would be 60 degrees. I would be doing 240 minus 180, which is 60 degrees. So I recall my step 2, which is kind of locating that triangle or locating that appropriate finger on my hand. So I want to locate the 60 degree finger. So 0, 30, 45, 60. This is the finger that's going to get bent down, and there's my fancy nail. Okay, so this is the finger that gets bent down. So we have to write the sine, cosine, and tan of my reference angle. So sine 60, cos 60, tan 60. So let's look at all of them. The sine and the cosine will have the 2 that's on my palm. So let's look at the sine. I have 1, 2, 3 fingers. So I would put a root 3 over 2. For cosine, I have 1 finger, so I would write a root 1 over 2. And then my tan would be the sine fingers divided by the cosine fingers, which is root 3 over root 1. And then you can clean these values up. So this would be root 3 over 2. Square root of 1 is 1, so this would be 1/2. And then root 3 divided by 1 is just root 3. And my last step would be to focus on my rotational angle. So sine of 240 is going to look like a root 3 over 2. Cosine of 240 degrees is going to look like a 1/2. And tan of 60 degrees is going to look like a root 3. But I would use my cast rule to figure out what the positive or negative signs would look like, and I'm in quadrant 3, so I'm going to go ahead. Sine will be negative, cos will be negative, and tan is the only thing that would be positive because that's what my quadrant 3 cast rule tells me. 330 degrees, so just a different quadrant. I draw my angle out. 330 degrees is located here. I'm going to do that in red. So there's my rotational angle. I write the angle on top of my arm, or like the swing part. We have to locate our reference angle. This is theta ref. So to get my theta reference, I do my full 360 degrees. And I subtract off that full rotation I've already went, like the almost full rotation, and I'm left with 30 degrees. So this reference angle is 30 degrees. I locate my 30-degree finger or my 30-degree triangle. There's an imaginary 2, an imaginary square root. So my 30-degree finger, I start at 0, 30. So this is the finger that gets bent down and my fancy nail. That's the finger that gets bent down. So now we write our sine 30, cosine 30, tan 30. We're just going to write that down. So let's look at the sine first. I have one sine finger. So square root of 1 over my palm, which is a 2. This simplifies to 1/2. I look at my cosine fingers, 1, 2, 3 cosine fingers. So this is root 3 over my palm, which is a 2. And when I do the tan ratio, I take my sine fingers, divide by my cosine fingers, and then simplify that value, which square root of 1 is 1. Square root of 3 is just square root of 3. Those are my reference values off my reference triangle. Whoops, I made this a little bit big. And now I'm going to do my sine of 330. It's going to be related to the 1/2. My cosine of 330 is going to be related to the root 3 over 2, and my tan of 30 is going to be related to the 1 over root 3. I come back and draw my cast rule. My rotational angle is located in quadrant 4, so sine is negative, cosine is positive, tan is negative. Okay. Knowing your finger trick is super handy because when you get to 30-1, they pick up right where you leave off, and now they'll teach you radians, and then your finger trick stays exactly the same, and it becomes super handy to use. You will use it all over again. All of this trig content is sort of the starting point of 30-1. Now what we're going to do is we're going to work backwards. They give us the ratio, and I want to use, find the angles that were associated with that ratio. So the first thing I need to do is draw my hand out, and I need to locate the reference angle off of my hand or my triangle that relates to having a root 3 and a 2 for cosine. So this root 3 tells me I'm looking for 3 fingers on the cosine side, which is the left. Okay, so I'm going to locate 1, 2, 3 fingers on the left, and then that's telling me that this was the finger that was bent down to get the fact that I have 3 cosine fingers. And then you'll notice here, well, there's 1 finger left over, that would be my sine finger. Okay, and you have to also remember there's the 2 on your palm, so I'm only looking literally at the 3. So this is telling me my reference angle, this is 0 degrees, this was 30 degrees, my reference angle was 30 degrees. My step 2 would be to locate which quadrant my actual angle is in. So I would use the fact that this is a negative sign, which is telling me I'm in quadrant 4 or I'm in quadrant 1, because there's 2 places where cosine could be, whoops, I did that wrong. I want to do where cosine is negative, and I just did the values where cosine was positive. So I need to be in quadrant 3 and 4, or 2 and 3. So I have to have a quadrant 3 and a quadrant 2 answer where cosine is negative. And my step 3 would be to just draw my 30-degree reference triangle in each location. So there's my quadrant 2 reference angle. There's my quadrant 3 reference angle. My goal is to find the rotational angle now that leads to these reference angles. So in this case, one of my answers will be 180 minus 30, which will give me the rotational angle of 150 degrees. My other angle would be I travel to the 180 mark and I go a little bit more, which is the 30 degrees. And therefore my rotational angle would be 210 degrees. Okay. Now, over here, I'm just going to ignore use calculator and cast, use special triangles. I'm going to use my finger trick because that's what I like to do. And I'm hoping that's what you like to do. I know you guys as a class and you guys do work very well with visuals, so this is really good. In the next question, I'll show you how to use your calculator. So let's start again. We draw our handout. There's an imaginary 2 on my palm. This is my square root. Again, we're always using our right hand. Okay. This one tells me I'm using the sign fingers, and the sign fingers are on the right-hand side. Right-hand side. So I want one sign finger on the right-hand side, which means this is my finger that's getting bent down. Okay, and this is just like you don't draw the hand out, you just look at your hand in front of you, bend your pointer finger down, and then go from there. So literally I need to look at the fingers to locate my reference angle, which the orange finger that went down represents my 30-degree angle finger. Step 2 would be to locate the quadrants. C-A-S-T. We are looking for sine being positive, because that's what my ratio is a positive value. So sine is positive in quadrant 1 and 2. So I will have an answer in quadrant 1 and quadrant 2. Third step is just to draw that reference angle out in each quadrant. So here's my 30 degrees in quadrant 1. Here's my 30 degrees in quadrant 2. My goal would be to find the rotational angle. So this is a theta rotational. And in this case, my theta rotational is that angle. So in the first example, my reference and my rotation are exactly identical. In the second example, if I travel fully to the 180-degree line, I would go a full 180, but I want to subtract the 30 degrees off, which I haven't gone, and I would get a total of 150 degrees. So the answers in the problem are the angles that I found in each of these examples. So those two are my answers. Now you can only use your finger trick if you have 1 finger, 2 finger, or 3 fingers, because if it starts to give you something that doesn't represent on your fingers, you can't use it. Okay, you can't use the special triangles, you can't use the fingers. So in the next example, they give you sine, cosine, tan of things that are not on your fingers. There's some ugly decimals, and so we're going to have to use our calculator to solve for the reference angle. So our calculator is sort of acting like our fingers and giving us the exact value when our fingers can't. Okay, again, if you're thinking of using special triangles or the fingers, you just use them appropriately. So you're either using special triangles or fingers, and if it's not possible and you don't remember a value that comes off of that triangle or the fingers, then you have to use your calculator. So my first step stays exactly the same. I find theta reference, but I just use my calculator. So I'm going to use my tan inverse function, and I'm going to only put a positive angle or positive ratio in. So we only want to be positive. I shouldn't do it that way. Let's just use orange. We only want to make this always positive because we're dealing with our reference. So on our calculator, this is what's going to help us find the reference angle. We're going to go second tan. Whoops, it doesn't pick that up. Second tan, and I'm going to put the value that they give me, 1.5689. and then enter. The reference angle is 57.48 degrees. I'm going to round to the nearest degree, which means I have 57 degrees. So this is going to be 57 degrees is my reference angle. So instead of using my fingers, my calculator gave me the reference angle. I'm going to locate my quadrants, same steps as above. I'm looking for a tan value that's positive. So that would come from the T quadrant and the all positive quadrant. And then I just locate my answers. I'm going to have an answer in quadrant 1, and I'm going to have an answer in quadrant 3. So my quadrant 1 answer is going to look like, here's my reference angle of 57 degrees. My goal is to find the rotational angle, which will be exactly 57 degrees. And in the second or the third quadrant, this is a 57-degree reference triangle. And my goal would be to locate the rotational angle, theta, which is 180 plus that reference, which is a little bit more, 57. And I get that my angle is 237 degrees. So we're literally doing the exact same steps, except now we are putting in the reference angle by using our calculator because we're not able to use our fingers. Let's do the next one. My theta reference would be sine inverse. And again, we ignore the negatives. We only enter the positive value in. So we are going to be entering in our calculator 0.2864. The negative is referring to location, not anything else. So we're going to use our calculator, second sine, and we're going to type in the 28864, and I get an angle of 16 point blah, 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 blah. I want to round to the nearest degree, so that would be 17 degrees as my reference angle. So this would be a 17-degree reference angle. Now we take into consideration that the sine value is negative. It gives us location on our standard position grid, if you want to call it that. Sine is negative in the C quadrant and the T quadrant, which means my answers are going to be coming from quadrant 3 and quadrant 4. So here's my 3, here's my 4. I'm going to draw a 17-degree reference angle there, 17-degree reference angle there. So this would be my rotational angle, and that would be my rotational angle. So in this case, my rotational angle is I went to the 180-degree line and traveled 17 degrees more. So that would be 197 degrees. And this one, if I went the full circle, I would have traveled 360, but I was 17 degrees short of traveling the full circle. And this would have also led me to 343 degrees. So that's our lesson for today. I will hand out, or on D2L, you can find a practice quiz. I call it a practice quiz. It used to be one of our old outcome checks. So you can see what kind of questions are being asked there. The sub has that handy for you to hand out. Please make sure you're working on that. And I'm not going to post the answers yet, but at some point I will post the answers. That would be all of the content that you need to know for this entire first part of Trig. So make sure you practice, 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 because tomorrow's lesson we're going to start to move on to sine and cosine law, which is dealing with triangles that don't have our 90 degrees, which is going to be completely brand new to you as well. Okay, there's also questions in the textbook for you. You can practice. You don't have to use the method they're asking you to use. You're free to choose whatever method you want to use. You can use your calculator, cast rule, special triangles, hand trick, any of that stuff, whatever seems to be most in tune with how you learn. And we won't ask you to do it a special way, but we will ask you to do it without the calculator. So it is important to make sure you're aware of the hand trick or your special triangles, depending on kind of what you like better. I kind of focused on the hand trick here. I will also post Mr. Little's solutions to the lesson because he kind of likes to use the special triangles, or at least in his lesson he shows the special triangles a bit more, so that way you can figure out which method you like better. Again, as always, if you have questions, feel free to email me.